Hello everyone, welcome to Tuteetute. In this particular video, we will see the important questions related to signals and systems. Okay, and this particular preparation towards TS GENCO 2023. So the first question is the period of the function cos of pi by 4 into t minus 1. So what is the function here? Cos of pi by 4 times t minus 1. So this is the given signal. They are asking us to calculate the time period of this particular function. So what is the general representation of the cos function? A cos of omega t plus phi. So by comparing these two, we can able to understand that omega is equal to pi by 4. Okay, omega is equal to pi by 4. I am writing only the necessary things because time period is not related to amplitude and phase, so I am not concentrating on those two. So if you multiply this pi by 4 inside, you will get pi by 4 into t minus pi by 4. So actually phase is equal to minus pi by 4 and amplitude A is equal to 1. But I am writing here only angular frequency, that is omega is equal to pi by 4 radians per second. Okay, and this is equal to, we can write 2 pi f, and from this you can able to write f value. F is the normal frequency measured in hertz. So here pi will be cancelled and these two you can send this side. That means you will get a frequency is 1 by 8. Okay. So time period is equal to inverse of the frequency. So that is equal to 8 seconds you will get. So this is the time period of the given signal. So 8 seconds means this is the correct option. So in this way we can able to calculate the period of the normal signal. So on this particular calculation of the time period, so many problems will be there. Okay, instead of giving only one cosine function, you can work with sine function. You can work with the combination also. That means cos and sine. The addition of the two cos signals, addition of two sine signals, and addition of cos signal and sine signal. And in that variation is also there. How the variation will be available means this particular angular frequency, whatever the angular frequency pi by 4 is there here, that may include pi, that may not include pi. Like that different variations you can able to try on this particular model. That means in the calculation of the time period. Okay, so you can practice lot of problems based on this particular thing. Next we will see the another question, that is a continuous time system is governed by the equation 3 times of y cube of t plus 2 times of y square of t plus y of t is equal to x square of t plus x of t. That is actually system equation. Okay, the relationship between input and output. So for that particular system, you can consider input is x of t and output is y of t. So like this we have one particular system. And the relation between those two, x and y, is given by this particular equation. Okay, and y of t and x of t respectively are the output and input. Okay, the system is, if you see the options, linear, dynamic, linear, non-dynamic, like this we have. Okay, so all the options are talking about linearity and dynamic nature. That means we need to check these two conditions. Okay, by seeing the equation itself, we can able to tell system is non-linear, because here power you can able to observe. So system is non-linear because of the powers. Next, dynamic means what it is actually memory, with memory. We have the type of the systems like static system and dynamic system. Static means what? Static means memory less. Okay, dynamic means with memory. So what is the meaning of that one? If you see the definition of the static system, how it will be there means the present output should depends only on the present input. Okay, you are checking the output at certain time instant, so that needs the input at the time instant only. That means it should not require the past inputs, it should not require the future inputs. If the present output depends only on the present input, then that particular system is the static system. This condition is satisfy the this particular given input-output relationship. You can see here everywhere we have t only. Okay, so for example you are calculating output at t is equal to 5 seconds. So you need to substitute t is equal to 5. So 3 into y cube of 5 plus 2 into y square of 5 plus y of 5 is equal to x square of 5 plus x of 5. You see the input terms. X square of t and x of t is there. That means x square of 5 plus x of 5. So you require the input also exactly at t is equal to 5 seconds only. For example, here you have x of t minus 1. Then that means 5 minus 1 means input requires at t is equal to 4. That means that is the previous input. So like this we can able to understand. Okay. So this the given system, basically the present output depends on present input only. That is what you need to understand. Okay. So it depends upon the present input only. That means it is a static system. That means a non-dynamic system. Non-dynamic system. So the given system is non-linear and non-dynamic. So option D is the correct option. Like this we can able to solve. So you should have the command and definitions of all the types of the systems. Now we'll see the next question. Which one of the following input and output relationships is that of a linear system? Okay. The name itself is giving the information that the relationship between input and output should be linear. Linearity means what? If you make some change in the input, same change should be reproduced at the output. Okay, then we can tell that is called linearity. But if you see here, which one is followed by that particular linear system characteristics means the straight line passing through the origin. That is what we can able to tell linearity. So by seeing the graphs easily we can able to identify option 4 is the correct option. Like that we can able to tell. Okay, here for the linearity some DC value is added. That's why the curve is shifted. So that is nothing but if input is 0, output must be 0. That is also one of the criteria of the linear system. But in the option A, even though input is 0, some output is coming. So it is non-linear. Here you can able to tell it is exponentially increasing signal. So it is non-linear. Here some discontinuity you are observing here. So it is also non-linear. And option 4 is already I have told that is a linear. Okay. Now we'll see the next question. If a plot of a signal x of t is as shown in the figure. Okay, this is a given signal that is x of t. If you observe this signal, the signal is having the non-zero amplitudes from -1 to +3. Okay, when time changes from -1 to +3, the amplitude of the signal changes like this. Okay, at different time instances it has different amplitudes. Okay, then plot the signal that is x of 1 minus t will be. Okay, x of 1 minus t we have to draw. So this is a signal we have to draw. So if you observe that particular signal, x of 1 minus t means x of minus t plus 1. Like this we can write now, x of minus t plus 1. So it is involving shifting operation and reversal operation. So what we need to follow first? We can able to follow shifting operation. So first thing we have to get x of t plus 1. Okay, is it right shift or left shift? Here if you compare this one with x of t minus t naught is negative. That means it is a left shift. Okay, so we need to shift the x of t signal by 1 second left side. Okay, left side we have to move. Then you will get x of t plus 1. After getting this signal, on this signal you need to perform time reversal operation. Then you will get what you want. Okay, so now first I am writing here x of t plus 1. So x of t plus 1 means, as I said earlier, we have to move this particular signal to the left side by 1 second. So actually the original signal starts from -1. So now the signal will be started from -2, -1, 0, 1, 2. The signal ends at 3 because of the shift to left side by 1 second. The signal will be ended at 2 seconds. Okay. Now same pattern we can able to take because of the time shifting there is no change in the amplitude. So same amplitude levels we can able to get. So what is this one? X of t plus 1. Okay, x of t plus 1 is nothing but this is the signal. Okay. Now what we need here, x of minus t plus 1. That means time reversal operation we have to perform. Here y-axis is there. Here amplitude is 1. Here amplitude is 2. Okay. So that is what we need to apply. So by shifting this particular signal to the left side, we got this one. Now if you rotate this one, I will draw here again properly. -1, -2, 0, 1, 2. And from -2 to 0, ramp is there. -1 to 0, some constant is there. Then it is raised to another amplitude level 2, then it is fall down -1 to -2 to -1, next -1 to 0, next to 1 to 2, we have this one, next it should fall down. It should fall down, then we'll get like this. Okay, here I did some mistake here, I forgot this particular structure, so you can able to take this one. Here amplitude is 1, here amplitude is 2. Okay, now just you make a time reversal. So if you make the time reversal, what we'll get, this is the y-axis now, this is the y-axis. Okay, so what we can able to do, you need to reverse the signal with respect to y-axis, then 0, -1, -2, and it is +1, +2. Whatever the structure is there on right side, that should come at the left side. Okay, suddenly fall down, then it will reach -2 here. Next here, what we need to have, this is 0 actually. At 0, the amplitude changes from 1 to 2. Okay, the amplitude changes from 1 to 2. 1 to 2, then it is maintaining 1, then it will reduce us like this. So like this we can able to take. So this is nothing but our required signal, x of -t + 1. Okay, so that means which option is the correct option here? We can tell option A is the correct option. Okay, now which one of the following systems is a causal system? So causal system means what? Causal system means the present output should depends on past input and present input. Like that we can able to tell either past input or present input or both. But the present output should not depends upon the future input. That is the main criteria. If you remember that one, remaining two things automatically will come. So totally three things are there: past inputs, present inputs, future inputs. So if the system present output is not depending on future inputs, then we can tell that is a causal system. So in the given options, which is a causal system, that is what we need to find. So here y of t is the output and u of t is the input. Okay, so if you observe these equations, if you observe, all are given for y of t, y of t, y of t, y of t. For example, we are measuring the output. Okay, output we are taking at t is equal to 0. That means input must be either at t is equal to 0 or t less than 0. So you should not have the inputs at t is equal to 1, t is equal to like that. Okay, so now we will check the regardings. Okay, so y of t is equal to sine of u of t plus 3. Okay, t plus 3 means what? It is it will be shifted to left side actually. Okay, it will be shifted to left side by 3 seconds. Next, y of t is equal to 5 into u of t plus 3 into u of t minus 1. So it is afterwards. Okay, it is 1 second delay. Here exactly u of t and it is 1 second advanced. Next it is 3 seconds delay, it is 3 seconds advanced. By observing the this particular equations itself, here advancing is there, here advancing is there, here also advancing is there. Only here we don't have the advance. So we can able to tell this is the answer. Okay. Figure 1, figure 2 show respectively the input x of t and to a linear time invariant system and the impulse response h of t of the system. So input is given, impulse response has been given. The output of the system is 0 everywhere except for the time interval. That means whatever the output y of t is there, that is non-zero for how much amount of time duration. That is what we need to calculate. In order to do this particular problem, actually y of t for the linear time invariant systems, y of t is given by the convolution between input and impulse response. Like this we have to take y of t is equal to convolution between input x of t and impulse response h of t. But here they are not asking about y of t. Okay, about the waveform of the y of t or the signal y of t completely. Here they are asking us only for what is the time duration. Okay, for which this y of t is non-zero, or in which time interval this y of t is existing. That is what they are asking. For that you no need to perform the convolution like integral tau is equal to minus infinity to plus infinity, x of tau, h of t minus tau, all these things you no need to perform. Okay, without performing that one, we can able to do the answer. That is, we know that for example x of t starts at what interval. For example, here I am taking this is x of t starting value is a, that means t is equal to a and it is ending at t is equal to b. h of t starts at t is equal to c and h of t ends at t is equal to t. That means here a is equal to b, sorry, a is equal to 1, b is equal to 4, c is equal to 0 and d is equal to 2. So what we need here, okay, from where this output will be started, at what time this output will be ended, that is what we need to do. Okay, so y of t is having the time limits, that is a plus c to b plus d. That means addition of the starting time instance, that is what we have to take. So a plus c. Next, it will be ended at the time instance where these two signals are ended. Addition of those time instance we have to take. So b plus d. So 1 plus 0, that means this value is 1. Next 4 plus 2, that is 6. That means from 1 to 6, this particular signal will be available. Y of t signal will be available. So by observing the options, we can able to tell option D is the correct option. And now we will see the next question. The impulse response of the system is h of t is equal to del of t minus 0.5. That is the impulse response. If two such systems are cascaded, okay, so along with this one we have to take one more system and those two are cascaded, the impulse response of the overall system. Okay, so we have h of t here and we have to take one more h of t, one more system like this. These two are in cascaded. Okay, so the resultant system will be having the impulse response. We know that is the convolution of these two. So h of t is in convoluted with the h of t, like this we have to do. So about this one they are asking, so what is h of t? Actually they have given del of t minus 0.5, that is in convolution with del of t minus 0.5, like this we have to do. Whenever any signal is convolving with del of t, we have to take the same signal, but that should be shifted by the impulse signal shift. That means x of t, it is in convolution with del of t minus t naught. Then what is the answer for this one? Here what was done actually? X of t is in convolution with shifted impulse signal. So we can tell that whenever one signal is in convolution with del, we'll get the same signal, but here shifting is there, so that shifting also we have to take into the account. Answer is x only, but here shifting has been taken because of the shift of the impulse signal. Here also you can think like that only. You assume this is one general signal, this is an impulse signal, or this is one general signal, this is impulse signal, like that you can able to take. So one general signal is in convolution with del, that means you should get again the general signal only, but how much shift is there in the del, same shift you have to take in the result also. That means del of t minus 1 we will get. So del of t minus 1 means option C is the correct option. Now the next question is, two rectangular waveforms we have to take of duration t1 and t2. Since they have mentioned t1 and t2, those two rectangle pulses are of different pulse width, like that we need to assume. So here I have taken one rectangle pulse and they did not mention whether it is coming from left to right, all those things we don't know. So in any manner you can able to take, you can able to keep this particular rectangle pulse like an even signal. That means it starts from minus t1 by 2 to plus t1 by 2, or like this also you can able to take, whatever it may be. So 0 to t1 I have taken and I am allowing this particular condition. What is that? The duration is t1. Okay, now I am taking another rectangle pulse of different pulse width, that is t2. So like this I have taken, and these two are in time domain and these two are convolved. That is what they have told. Okay, what is the shape of the resulting waveform? It is very standard one. When we convolve two rectangle pulses of same pulse width, for example here t seconds, here also t seconds is there, then we are going to get here triangle signal. Okay, but when you perform in between two rectangle pulses of different pulse width, then surely you will get here trapezium signal, you will get trapezium. Okay, so trapezium is the correct option. You need to practice the problems. Just it is not about just remembering these important points here. That means convolution between the two rectangle pulses of the same pulse width, you will get the triangle, like that you should not remember. By practicing you can able to understand what is the reason we are getting like that. Okay, so what will happen means convolution means one signal is fixed, another signal is moving over the fixed signal. While the second signal is moving over the fixed signal, what will happen means the area of that particular convoluted portion, what will happen, it will be continuously increases reaching the maximum value and then starts decreasing. But here what will happen means first of all it will increase, then it is maintaining the constant area, then it will decrease. That is what we can able to observe while the second signal is moving over the first signal. So if you have that idea, you will not forget about these things. Okay, so practice as many problems as much. Okay, then a discrete LTI system is non-causal if its impulse response is, okay, they are telling about the non-causality. So non-causality means if you observe here, we need to talk about the non-causality with respect to impulse response here. With respect to impulse response means h of t, because they have given in discrete nature we can take h of n. Okay, so with respect to this impulse response we need to comment on what is that causality. Okay, causality means we should get this h of n is equal to 0 for all negative values of n. If you want to talk with respect to continuous domain, h of t is equal to 0 for all negative values of t. Okay, anyhow, here the question is related to discrete domain. So h of n must be 0 for all negative values of n. That means we should not have the impulse response for negative values of t. So given thing is impulse response only. It is u of n minus 2 is representing the shifted version of the u of n to right side. The right side means it is on positive side only. So it is causal. It is u of n causal. It is also u of n causal. But it is u of n plus 2. U of n plus 2 means it is left shift by 2 seconds. Okay. Like this we have to take minus 2, minus 1, 0. Like this. That particular impulse response will be available, then it must be multiplied with a power n, but you will be having the non-zero values from n is equal to minus 2 onwards only. So for n is equal to minus 1 and for n is equal to minus 2, you have the impulse response is nothing but that is non-causal only. So this is the non-causal, that is the option. Okay, now again same problem is there. So now the next question is, a square wave is defined by x of t is equal to a and minus a, but a is available when you take the time that is from 0 to t naught by 2, and minus a we can take when time is in between t naught by 2 to t naught. Okay, so this is the criteria we have to take into the consideration. So here I am taking the given x of t signal. How this particular signal is there? T is equal to 0 to t naught by 2 and t naught, like this we have to take. And this is the given signal a and minus a, and this portion is periodically extended outside this interval. Okay, so it is the periodic signal. Okay, this will be repeated continuously like this. Like this we have to take. Okay, this is minus t by 2, this is minus t naught, like this it will be extended. Okay, up to from minus infinity to plus infinity. What is the general coefficient an in the Fourier expansion of this particular wave? Okay, they are asking about an. We have three coefficients in case of the trigonometric Fourier series: a0, an, bn. Actually a0 is the DC value and an and bn are representing with respect to frequencies only. Okay, these are the related to harmonics. So what is the an value? So can we solve this particular question? Means it will take lot of time, okay, by solving that one, but we have some rules. Okay, an is actually existing for the even signals. Okay, but the given signal is odd signal. How can I tell that one? So given signal is x of t, it is satisfying x of t is equal to minus x of minus t. So the given signal is the odd signal. For odd signal, a0 is equal to 0 and an is equal to 0 and bn is not equal to 0. They asked about an, so answer is equal to 0. An is 0. So this is the correct option. How can I tell it is the odd signal? Means the signal is satisfying this particular rule. Okay, we'll check that one. So first I will take x of minus t. How can I take this x of minus t? This is the time reversal. So this is the y-axis. Just you rotate this one with respect to x. This part will come here. This part will come here. Na? So this will come here and this will go here. So like this we will take. Okay. This is the x of minus t. It is not enough. Here amplitude reversal is also there. So next I will draw x of minus t. That means now we have to rotate this one with respect to x axis. That means this portion will come here, this portion will come here. So what will come? So this will be available like this. Now you check, this is exactly equal to x of t only. So the given signal is odd signal. Since it is odd signal, we can tell an is equal to 0. Okay. Consider the following statements. Okay, in the next question, they have given Fourier series of any periodic function x of t can be obtained if. So they have given some two conditions they have given. We'll check that one. So integral time changes from 0 to 1, magnitude of x of t dt is less than infinity. They are telling that is one condition, and the second condition is finite number of discontinuities exist within this finite time interval. Okay. Which of these statements are correct? Okay, actually whenever Fourier series we have considered, immediately you need to remember that whatever the integrals we are going to perform in entire Fourier series, those integrations are over one period. Here they did not mention x of t is having the time period is equal to 1. So it is not the given thing. Okay, it is not actual one. Okay, so it is to be over one period. But here they have taken 0 to 1. So always there is no rule for all the signals time period is 1 only. So this is wrong. But this is correct only. Okay. Finite number of discontinuities are required. Finite number of maxima and minima are required. And if you perform the integration over one period, that must be finite. So here out of three conditions, Dirichlet conditions, one is satisfied. They are asking about which of these statements are correct. So we can tell only second statement is correct. That means option B is the correct option. Okay, like that we can able to consider. Now the next question is related to, I think, exponential Fourier series. We'll see that one. The complex exponential power form of Fourier series of x of t is. Okay, they have taken this complex Fourier series. If x of t is equal to, they have given the sigma b is equal to minus infinity to plus infinity del of t minus b. It is looking like impulse train, because if you draw that x of t signal, you take first b is equal to 0, you will get a del of t, b is equal to 1, del of t minus 1, that means shifted by 1 second, b is equal to 2, shifted by 2 seconds, b is equal to minus 1, shifted by minus 1 second, next shifted by minus 2 seconds. Like this it will be going. That means, what is this one? It is impulse train signal. That is what they have given. So they have equated this one to our exponential Fourier series. Then the value of k, ak they are asking. That means the Fourier series coefficient, exponential Fourier series coefficient they are asking. So ak is equal to, what is the formula? 1 by t integral over one period, as I said previously. So t is equal to minus t by 2 to plus t by 2. Like this we can take. And here x of t e power minus j n omega naught into t dt. So here people are using k, so I will also use k only without avoiding confusion. So e power k, omega naught means 2 pi by t naught, we can use, no problem, omega naught into t dt. Like this is the thing. Okay, so it is equal to 1 by t integral t is equal to minus t by 2 to plus t by 2. What is this x of t? You no need to substitute this entire signal. You no need to substitute this entire given thing. But you need to substitute the value in between minus t by 2 to plus t by 2. So what is t? T is equal to here 1 second only. So minus t by 2 to plus t by 2 means minus 0.5 to plus 0.5. In between these two, what is there? Impulse signal is there. So you can take here del of t e power minus jk omega naught t dt. So it is equal to 1 by, what is the time period value? 1. So 1 by 1, what is the value of this one? According to the impulse property, when you have like this, what is the answer? You consider this is the general signal, then at what time this particular impulse signal is existing, at that particular time instant we need to take the value of this one. So impulse is existing at t is equal to 0, so e power 0 is 1. So that is equal to 1 is the answer. Okay, 1 is the answer. So you may have doubt for this particular integral, so I will explain that one once again. So integral t is equal to minus infinity to plus infinity x of t del of t minus t naught into dt. You know this formula. Okay, what is the answer for this one? X of t naught. So now this particular integral is satisfying this particular equation. You can check that one. Limits are no need to have from minus infinity to plus infinity, but within this range the simple signal must be available. That is our criteria. So t is equal to minus infinity to plus infinity x of t. So what is x of t here? This is the x of t, one general signal, e power minus j k omega naught t, that is x of t, and shifted impulse signal is nothing but del of t minus t naught. So here t minus t naught is nothing but t naught is equal to 0 we got. So what is the answer? For this general signal we need to take t is equal to t naught. That means in this particular signal substitute t is equal to 0. So e power 0 means 1 will get. So total integral value is 1. You are not performing any integration. We have the formula, that one we are applying here. So this integral value will get 1 into 1 by t is equal to 1 only. So answer is 1. That is what we got here. Now the next question is, a voltage signal v of t has the following Fourier transform. Okay, they have given certain Fourier transform they have given. How this particular Fourier transform is there, just to observe that one. So v of t having the Fourier transform v of omega or v of j omega, that is equal to e power minus j omega d. Okay, when mod omega less than 1, what is the meaning of mod omega less than 1? You need to take positive values of omega, you need to take negative values of omega. For example, if you take positive values of omega, mod omega is omega only less than 1. If you take negative values of omega, mod omega will become minus omega, that is also less than 1. Okay, that is what you need to consider. So by combining these two, how can we write this particular thing? Here omega is less than 1. If you multiply with minus, omega is greater than minus 1. That is what we will get. So these two conditions are same. By combining these two, now what we can write here? Omega, it is greater than minus 1 and it is less than plus 1. So this is what they have given here. Okay, this condition only we can give using modulus also. That means when omega changes from minus 1 to plus 1, what is v of omega? E power minus j omega d. That is what they have given. Otherwise, this particular v of j omega is equal to 0. Okay, that is a given thing. The energy that would be dissipated in 1 ohm resistor fed from v of t. Anyhow, resistance is 0. We need to calculate the energy. Okay, so energy of v of t we have to calculate. What is the formula? Integral t is equal to minus infinity to plus infinity mod v of t square dt. But do you have v of t? No. What we need to do? You may get idea. That is, we can find here inverse Fourier transform so that you will get here v of t. But it is lengthy process. Even you don't have time domain signal, we can calculate the energy by having the frequency domain signal using the Parseval's Fourier transform. Okay, Parseval's theorem in the Fourier transform, the energy of v of t is equal to 1 by 2 pi integral omega is equal to minus infinity to plus infinity mod of v of omega square into d omega. So energy can be calculated using the frequency domain signal also. This is very, very important. Okay, so people will think that, okay, some students will think that we can calculate the energy using this formula. Okay, by having the time domain signal. No need. Okay, always we no need to apply this one. If you have v of t, you can able to apply. But if you don't have v of t, if you have v of omega also, you can able to calculate the energy in a direct method by having this particular formula. Okay, so it is Parseval's theorem only from the Fourier transform 1 by 2 pi. That is what we need to apply. So here I am performing that one. So 1 by 2 pi integral. Where to where we have non-zero value of the v of omega? From minus 1 to plus 1. So omega is equal to minus 1 to plus 1. Okay, modulus also you should not forget, modulus of e power minus j omega d square d omega. That is what we need to calculate. This is the energy. So it is equal to 1 by 2 pi integral omega is equal to minus 1 to plus 1. Modulus of e power j theta is 1. Okay, e power j theta is equal to cos theta plus j sin theta. If you take modulus, you will get square root of cos square theta plus sin square theta. So square root of 1, that means modulus will become 1. Okay, so 1 square is again 1. So for 1 integration is omega, since we are performing the integration with respect to omega. So limits are minus 1 to plus 1, that means 1 by 2 pi. Here 1 minus of minus 1, that means it is equal to 1 by 2 pi into 2. 2 will be cancelled, answer is 1 by pi. So option C is the correct option. Like this we can able to solve the question. So here getting the idea immediately, that is very important. Okay.